We are going to be talking about chapter 5. Reminder, your next exam is 2 weeks from today, March 10th. This will all be on that exam. Naming ionic compounds. And naming acidic compounds. Just 2 things, but this will take the whole time. And you might walk out of today's classroom a little unsure, and that is fine because there's just a lot of rules that you have to be able to walk through, and you will have to memorize those rules. If you walk out of here and you're like, what just happened? Go to Katie's session on Sunday at the CLC. It is all dedicated to what we're learning today. So if you walk out of here confused today, go to the CLC, and then we will have a worksheet all on this on Monday. Everyone have this down? Good. Remind me, what are the 2 types of cations? What do we call them? Type 1 and type 2, pretty simple. Can anyone remind me what a type 1 cation is? We learned this on Wednesday. One charge state. Where do these tend to be on the periodic table? Main group elements. And then, so these are main group elements. And then what are the 2 exceptions in the transition metals? Does anybody remember? Silver and zinc, yes. So Ag plus and Zn2 plus, and then also NH4 plus. So these are the elements that can only, or the cations that can only have 1 charge. And do we have to, so if they can only have 1 charge, do we have to tell the charge? No. So don't have to say charge. Because any chemist worth their salt would be able to look at the periodic table and say, well, barium is in group 2A, it has a 2+ charge, instead of having you tell them what the charge is. Type 2 cations, what are those? Multiple charge states. Where do these tend to be? They tend to be transition metals, and then what 2 additional? And tin. Yes. So lead and tin and the transition metals, except for silver and zinc, all of these have multiple charge states. If you just say lead, a chemist can't figure out what that charge is supposed to be, because you look at the periodic table, you don't know. You have to specify which charge state of lead it is. And so how do we specify that? Roman numerals and parentheses. If you're not quite up on your Roman numerals, just know we're only going 1 through 5. So just make sure you have Roman numerals 1 through 5 down if you can't remember them. You can ask me or Chris just for a refresher on that. It'll take 2 seconds. So these are our cations these types of cations that I introduced on Wednesday. Now we're going to go into naming anions. Naming anions is a little more complicated. You tend to have to change the ending of your anion. So does everyone have this written down? Great. I am going to move on to naming anions. First, we're going to start with monatomic anions. And all monatomic anions end in "ide." So you're going to change the name of the element to end in "ide." So what's a monatomic anion? What? Anyone remember? One element, one type of atom. So these are things like N3- nitride, O2- oxide, Cl- chloride, P3-. So what do you think that's going to be? Phosphide. So you take the first syllable of the element and you add "ide" to it. Now this is where cations and anions differ. For example, sodium can refer to Na or Na+. So it can refer to the neutral state or the charged state. However, chlorine refers to the neutral state. Chloride refers to the charged state. So if you say chlorine, you mean Cl. If you say chloride, you mean Cl-. And on the next slide, we'll put these together. For example, the simplest example we have, which is NaCl. What's the name of my cation? Sodium. Okay, we don't change it. We know it's Na+, just sodium. And then what's the name of my anion? Chloride. So it's just when you name an ionic compound, you name the cation, then the anion, just like it's written. So sodium chloride. What would this be? Magnesium oxide. What about this? Potassium nitride. So it doesn't matter how many of the cation or the anion have, it's still just potassium nitride. Because if you tell a chemist potassium nitride, the chemist knows that K is 1+ and N is 3-. So if you say potassium nitride, they will be able to give you that ionic compound. And then the same goes for example, BaF2. What's this? Barium fluoride. I do want to mention that it's very important that you you keep the capitalization correct in terms of your atomic symbols, because, for example, capital C and lowercase o is cobalt. That's CO, cobalt. However, capital C and capital O is carbon monoxide, because uppercase O is oxygen. Okay, so you have to be very careful when you're writing your atomic symbols that you have the correct capitalization. First letter capitalized, second letter not capitalized. So these are type 1 cations with with monatomic anions. Let's do type 2 cations with monatomic anions. These, when you name them, what do you have to do with type 2 cations when you name them? Right, what do you have to specify? The charge. So you have to figure out the charge by how it balances with the anion. For example, if you just call this iron oxide, that's not enough information because there are multiple iron charge states. What we do here is we figure out the charge on iron. First, we figure out, okay, we have Fe, and that has a charge. We don't know what the charge is. And then we have O2 minus. Now, because it's a 1-to-1, where's my negative? There we go. Because it's a 1-to-1, what does the charge on the iron have to be to balance out the oxygen? 2+, which means, so that's going to be 2+, which means this is going to be iron 2 oxide. Fe2O3, we have 2 Fe's, and we don't know what the charge is, and we have 3 O2 minus. So what's our overall negative charge? -6. So what does our overall positive charge have to be? +6. If we want a total of +6, what does the charge of each of these two irons have to be? 3+. Iron 3 oxide. Questions on that? I might ask you to go in the other direction, where I'll give you the name and you have to give me the formula. All right, so we did formula to name. Now I want you to go name to formula. For example, if I say manganese 4 sulfide, what's the charge on manganese? Don't look at your periodic table. 4, because I told you what it is, okay? So it's Mn 4+. Now you can look at your periodic table what the charge of sulfide is. 2 minus. And you know it's, since it's sulfide, you know it's a monatomic anion, it's S2 minus. What do we have to do to balance these charges? Multiply sulfide by 2, so it's going to be MnS2 is manganese 4 sulfide. How are we doing so far? Let's do some practice problems. Where I give you the formula, I want the name. Where I give you the name, I want the formula. Does everybody have this down? Okay. Practice. Raise your hand if you need help. By the way, the Roman numerals, I don't care if you have the bars at the top and the bottom, but I do care that it's actually Roman numerals, not in our number system. So you can't write a 3, you have to write 3 capital I. Type 1 or type 2? Type 1 or type 2 cataracts? Type 1. So the type 1 doesn't tell you the chart, it tells you whether you can tell what it is with other people, right? So it can only have one chart, so you don't need to put the chart there because anyone who looks at the chart will tell them. Yeah, there you go. So fun to be here. Well, we didn't because look, I did.
Oh, right.
That's the whole point. Yeah, so I did it start. So how many CL? Also, be careful. You're gonna get in trouble with your capitalization. There you go.
Lowercase rules.
And then also. Can I go over them? It's very important that you do this as a stepwise process. Don't just look at the name and kind of feel out what you think the formula is, or vice versa. You have to actually go through and ask yourself these questions along the way. The first thing I want you to identify is, first of all, is this an ionic compound? But these are all ionic compounds, and we'll get to identifying ionic and covalent on Wednesday. Yes? I will address that when I get to number 3. They're the only 2 you need to know. There are more, but they're the only 2 that you need to know. I will address that. Yeah. But the first thing, once you identify as an ionic compound, the first thing I want you to ask yourself is this a type 1 or a type 2 cation? Is lithium a type 1 or a type 2 cation? Type 1, because it is in group 1A. If you look at the periodic table, group 1A elements are always 1+. It can only be 1+, so is it type 1? Do you have to give me the charge? No. So it is lithium. And then what is our anion? Sulfide, because it's the monatomic anion of sulfur, which means it's sulfide. I saw a lot of people put lithium 2 sulfide. That is wrong in 2 respects. First of all, it is not a type 2 cation. You don't need to put the charge. Second of all, 2 is not the charge of lithium. That's how many there are. That parentheses is the charge on the cation, not how many there are. And I'll address that on next 2 as well. So lithium sulfide is the answer to number 1. Cobalt 4 chloride. Is this a type 1 or a type 2 cation? Type 2, I gave you the charge. So what's the charge on cobalt? 4+. You don't have to look at your periodic table. You can just say, oh, she said 4+. Now, what is chloride? It is the monatomic anion of chlorine, which means it's Cl-. What do I have to do to balance out these charges? 4 chloride, so it's going to be COCl4. Make sure you do not capitalize the O and you do not capitalize the L. Elliot asked, why are tin and lead the only 2 exceptions for the type 2 cations? They're not the only 2 exceptions. They are the only 2 that you have to know. And that's because they're the 2 most common exceptions. And one of the reasons is that down here, when we have d orbitals, elements can take and gain and lose electrons a little more freely. But also, so they're way down this, but also they're in this 4A, where you don't know the charge of 4A. I said you don't have to know the charge because it can depend. So that's how you know that tin and lead are type 2 cations, because if you look at the periodic table, you're like, I don't know the charge of that. That's how you know. Does that help? Thank you. So what type of cation is lead? Type 2. So we need to write the charge. Do we know the charge automatically? No, we have to figure out how it balances with the N. So what is N? Nitride, because it's the monatomic anion of nitrogen. So what's the charge on nitride? 3-. And we have 4 of those. So what's our overall negative charge? -12. So what does our overall positive charge have to be? 12. So if we have 3 leads and they need to make a positive 12, what's the charge on each of those leads? 4+. That goes in your parentheses. It's not how many there are, it is the charge on that cation. So it's lead 4 nitride. Does everybody understand that? The tendency is to write 3 because you have 3 of them. That is incorrect. It is the charge. Let's go into polyatomic anions. Does everybody have this down? Specifically oxyanions. Does anybody remember what I told you oxyanions are? On Wednesday? Based on the name oxyanion, what does an oxyanion have in it? Oxygen. It is an element followed by a certain amount of oxygens. The first rule for naming oxyanions is that the most common oxyanion of an elemental series ends in 8. I will explain what that means. Let's just write it down first. So the most common oxyanion of an elemental series ends in 8. For the chlorine series, that means chlorine followed by oxygens. Chlorate is ClO 3-. For the nitrogen series, NO3- is nitrate. For the sulfur series, actually I'm going to do the carbon series. For the carbon series, CO3 2- is carbonate. Bless you. For the sulfur series, what do you think this is called? Sulfate. That's wrong. It's with an F. And with the P series, the phosphorus series, it's phosphate. So you have to memorize these. But I will give you a mnemonic device to memorize these if you are just not good at just doing flashcards with us. You're welcome to just make flashcards and commit them to memory, but you're also welcome to learn this mnemonic device that I'm going to give you. I want everyone to have this down, and then I'm going to go on to the next page for the mnemonic device. Okay. Oh, sorry. There you go. We good now? Great. I'm going to write this down and then I'm going to explain how you use it. Nick, the camel ate clam supper in Phoenix. Each of the capitalized words corresponds to an 8. And there are 3 rules for how we determine what the 8 is. So the first 2 letters give the elemental series. So what do you think Nick will give us? Nitrate, the nitrogen series, because it's Ni. The number of consonants gives you the number of oxygens, and the number of vowels gives you the negative charge. These are all oxyanions, so the charge will always be negative. So for nitrate, not looking at the 8s I gave you above, how many consonants do we have in Nick? 3, N, C, and K. So it's NO3. How many vowels do we have? 1, so it's NO3, 1 minus. Let's try sulfate. How many oxygens should we have? 4, because S, P, P, and R are all consonants. So it's SO4, and then what's our charge? 2 minus, because U and E are the vowels. This is how you use this, okay? So if you come in on the test and you write Nick the camel ate clam supper in Phoenix, and then you use that for the rest of the test, that's good. I want you to be able to use this device. And once you get more familiar, I've been doing chemistry for a really long time, so I know all of these automatically, but I started with this type of device. I started with these mnemonic devices that helped me remember these things, to memorize these things, and then eventually over time they just became part of memory. Okay, so you're welcome to use this. If you're just like, I don't really like mnemonic devices, I'm just good at memorization, use flashcards and memorize them. What's up?
So camel is carbon.
Yes, so camel, because it's the first 2 letters, so camel is carbon and clam is chlorine. Okay. We use these names in the same exact way as we use other anion names when we are giving the name of an ionic compound. So nitrate is NO3 minus. So what is NaNO3? What would we call that? Sodium nitrate. We just put the cation name and then the anion name. Questions on this? What is Mg3PO42? Magnesium phosphate. Name of the cation followed by the name of the anion, because PO43 minus is phosphate. Yeah, that's a 4, PO4 too. Questions on this before we move on to other oxyanions in these series? It's not always going to be ClO3 or PO4. Sometimes you'll have more oxygens, sometimes you'll have less oxygens. And the names of those anions are in relation to the 8. So we have a table. So let me just write this out. Oops. Okay, so everything is in relation to the 8. If we add, it's okay. just go along with me and it'll be clear. So if we add 1 oxygen to the 8, it becomes actually, let me do per 8. So an example of, so chlorate is ClO3 minus. So what is ClO4 minus? Based on that rule, what is ClO4 minus? I added 1 oxygen, so it becomes perchlorate. Okay, all I did was add per because I added 1 oxygen to chlorate. If I subtract an oxygen, it becomes ite. So if I have ClO2 minus, what's the name of that? Using this table, chloride. And the final one is minus 2 oxygens is hypoite. So ClO minus is hypochlorite. And yes, you do have to memorize these rules. Notice that the charges for all of the chlorine oxyanions are the same. The charge does not change for any of these elemental series. Only the number of oxygens changes. Let's do some questions here. Can anyone tell me what SO3 2 minus is? So you have, what is sulfate? So sulfate is SO4 2 minus. So what did I do? I dropped an oxygen. So what does it become? Sulfite. I dropped an oxygen. It's 1 less, so it's sulfite.
So what was the original?
So sulfate is SO4 2 minus. You drop an oxygen, it's sulfite. Can anyone tell me what PO5, 3 minuses. Per phosphate. So what is phosphate? PO4, 3 minus. What do? We added an oxygen. It becomes per phosphate. Remember how I said if you leave this room confused at the end of the day, go to CLC. This is why if you're having a hard time getting this, that's okay. What's up? Yeah, that's a 3 minus charge. So can anyone give me the nitrite ion? So now we're going the opposite direction. I'm asking you to tell me what the formula is for nitrite. NO2, and what's the charge? 1 minus. So what he did was that he identified nitrate, which is NO3 minus, and he knows that nitrite has 1 less oxygen, so he says NO2 minus. Now we can combine these with our cations, all right? Does everybody have these written down? Okay, I'll give you a few more seconds. So we're going all the way through. We're on good on time. Okay, so now we combine this with our cations. If I say Li3PO3, first identify the cation. It's lithium. Is lithium a type 1 or type 2 cation? Type 1. So it's lithium and yes, and so the name of the anion is not phosphate because phosphate is PO4 3 minus 1 oxygen, PO3 3 minus is phosphite. Okay, so you have to do this stepwise. This is why you can't just kind of throw out some ideas that you maybe think are, kind of make sense for the anion. You have to go through the steps. How about CuClO2? Notice that the 2 is on the outside of parentheses, so the anion is ClO. What type of cation is this? Type 1 or type 2? Type 2, because it's a transition metal that's not zinc or silver. So it's copper, and we don't know the charge yet. So we're going to save that till the end. What is ClO? It's a chlorine oxy anion. And how many oxygens does it have in relation to chlorate? So chlorate is what? Chlorate. Yeah, what's chlorate? ClO3, 1 minus. So subtract 2 oxygens from that. Hypochlorite. Now we determine the charge on copper. We have Cu and we have 2 times ClO minus. So what does the charge on copper have to be? Copper 2 hypochlorite. First, identify the type of the cation. Then identify what the anion is and its charge. Balance that out with the charge on the cation. Those are the steps. Questions? Concerns? Is everybody concerned? We're not done. There is more. Yes. You know the charge on the CLO because for any elemental series in the oxyanions, the charge does not change. So because you know that ClO3 is 1 minus, ClO is 1 minus as well. Good question. Let's talk about acids. So ionics start with a metal or NH4 plus or H plus, but in the case of H plus, that ionic compound is an acid. Okay, so it's a subset, acids are a subset of ionic compounds, but you identify them because they start with H plus. The number of H plus will balance out the anion charge. So if we have H plus and Cl minus, how do we balance this out? What do we do this? Nothing. Because you have a +1 and a -1, they become HCl. How about H plus and SO4 2 minus? How many H's do we need? 2, because it's H2SO4. PO3 3 minus, how many H's do we need? 3, because we have a 3 minus charge, we need to balance it out with 3 positive charges. So you have 3 H's, H3PO3. So if it starts with H, 1, 2, or 3, 4, 5, 6, we won't go beyond 3. Starts with H, it is an acid in this class. As you go on, if you go on to 110 and 111, you will learn broader definitions of acids. But in our class, you just have to identify an acid by the fact that it starts with an H. And acids have their own naming system. So I'm going to let you all write this down, and then we'll go into the rules for naming acids. We good? Acid names are based on the anion. This is because acids all start with the same cation, and so the fact that you call it an acid, that indicates that it starts with an H, okay? But depending on your anion suffix, it will change how you name your acid. So acid name. If your anion ends in "ide," your acid name will be hydroic acid. And I'll give you examples of this after we write this down. If your anion ends in 8, it will just be ic acid. So, and then if your anion ends in ite, it will be us acid. I have some mnemonic devices for you, once again, if that's your thing. So for the first one, you could say, my ride has hydraulics. I goes to hydroic. The second mnemonic device is I ate some icky acid. So for example, if you drink vinegar, it doesn't taste good. I ate some icky acid. And finally, my favorite, dynamite is dangerous. I goes to us. Once you write these down, we'll go through some examples. Are we good? Almost. A couple more seconds. HCl, what's the name of my anion? What is the name of my anion? Chloride. Because H plus is my cation, Cl minus is my anion. That's the monatomic anion of chlorine, which we know that the monatomic anions are end in ide. That's chloride, which means it is hydrochloric acid. So what we did, what we did was we took away the ide, added ic and hydro in the front. H2CO3, what's the name of our anion? Carbonate, because that's our 8 of our carbon oxyanion series, which means our 8 goes to ic. I ate some icky acid. It is carbonic acid. I do want to mention that, so H2SO4 is sulfate. Sulfur and phosphorus are a little weird in that you add back a syllable. So this is actually sulfurous acid, not sulfus acid. Okay, so this is something that you do have to remember, that sulfate, instead of just taking the it away, you have to do sulfurous, not just sulfus acid. But sulfus acid sounds a little weird. You've heard sulfuric acid, phosphoric acid. So that's something that kind of you see here. So if you're like sulfus, remember it's sulfurous acid. So
Sulfuric acid.
Sulfuric acid, sorry. Burp. That is sulfate. Sulfuric. I was on to the next one. H3PO3. What's that anion called? Phosphite. Because phosphate is PO4 3 minus. Phosphite is one less oxygen, PO3 3 minus. So dynamite is dangerous. And remember, phosphorus is like sulfur in that you add back a syllable, so it's phosphorus acid. I goes to us, and with phosphorus, you add in that extra syllable. Phosphoric, phosphorus, not phosphic and phosphorus. How about HClO4? What is that anion? Perchlorate, because chlorate is ClO3 minus. Perchlorate is one more oxygen, ClO4 minus. So it ends in H, so it's going to become perchloric acid. So you only change the suffix. What about HClO? What's that anion? What's chlorate? Yes. So chlorate is HClO3. We subtracted 2 oxygens, so that makes it hypochlorite. Ite goes to us. Hypochlorous acid. Note the difference between hydrochloric and hypochlorous. So hydrochloric acid is when you add in the hydro and the ic from I. Oh, I'm missing an L there. Hypochlorous acid, you started with hypochlorite, and all you do is change the suffix from ite to us. Questions on this? Do you want some practice? Just a couple? No. Too bad, we're gonna do some practice. Just like 2. We're just gonna do 2, okay? And we're gonna practice this all Monday. And once again, if you're like, what? Go to Katie's session on this on Sunday. All right? I need some examples. Oh, I've got it. And then what do I want to do? Good, thank you. Okay, try those. I'm gonna go to the restroom.
Yeah.
So the first one, I was kind of on this one.
Yeah.
I drew
Okay. So,
Yeah, hypo for
Let me just give the names. And if you didn't get it, you can ask why. I will see you on Monday. Yeah, you're done. So if you're still a little confused on these two, raise your hand. Chris and I can talk to you, but you can go.
I'm sorry. It's the last class, you know.
And this is one of my favorite ones. But it's
Do you like torture? Is that what this is? It felt kind of bad. This Friday, that's why.
Yeah.